Okay, so here's another problem related to density or using involving calculation of density. So when you read this problem, let's figure out what data is given and therefore figure out how to calculate what we need to calculate. In this case, we know the mass of an empty graduated cylinder, which is, as you remember from previous discussion, is a piece of glassware that is used to measure volumes of liquids. And then to this graduated cylinder, 50.0 mLs of an unknown liquid was added, and then the graduated cylinder was measured, the mass of the graduated cylinder was measured again with the liquid, and it turned out to be 106.773 grams. What is the density of the liquid? So from previous session, you remember that density is equal to mass of a substance divided by its volume. In this case, we are being asked to calculate the density of the liquid. Do we know the volume of the liquid? Yes, we do. The volume of the liquid added in this graduated cylinder is 50.0 milliliters. Do we know the mass or weight of this liquid? Well, we don't know that directly, but we can figure it out. How? Now, this is the mass of the graduated cylinder with the liquid, and that is the mass of the graduated cylinder without the liquid. So how do you then calculate the mass of the liquid? Absolutely, by subtracting the two. So mass of the graduated cylinder with the liquid minus the mass of the graduated cylinder without the liquid will give us the mass of the liquid alone. When you carry out this subtraction, we get the mass of the liquid as 63.956 grams. Now this is a subtraction step, so your answer must be in correct number of decimal places. Please take a moment to make sure that it is. Okay. Now we are ready to calculate the density of this liquid by taking the mass in grams, dividing it by the density, the volume in milliliters. And when we do that, the density comes out to be 1.27912 grams per ml. The density needs to be in three significant figures because of the volume being in three significant figures, and that rounds to 1.28 grams per ml in three significant figures. The next problem is very similar to a problem that we did in a previous session. This is again using the whole idea of what displacement to figure out the volume of an irregularly shaped object. So in this case, pure silver and its density is given as 10.5 grams per centimeter cube at a certain temperature, has a mass of 5.25 grams. And then this piece of silver was added to water in a graduated cylinder. The initial level of water is 11.2 mLs. We need to figure out the rise, the final level. So once again, if you remember the picture before, this is the initial level, 11.2 mLs. When you drop the piece of silver in there, the level of the water will rise to a certain level, let's say X mLs. And the volume, the difference in the two volumes, this is the volume of the silver in this case. Okay, so let's try and therefore solve this problem and get the answer. So first step in this case, just as in the previous step, will be to figure out the volume of silver, because volume equals mass divided by density. Mass is given in this case as 5.25 grams, and if you divide that by density, 10.5 grams in the denominator and 1 centimeter cube in the numerator. Of course, 1 centimeter cube equals 1 ml, so that we have the volume in mLs. Grams also crosses out. This gives us a volume of 0.500 mLs in 3 significant figures. Why 3 significant figures? Because both the mass and density are given in 3 significant figures. So in other words, the rise in volume from 11.2 ml is 0.500 ml. So the final level of water in this case will be starting from 11.2 mLs plus 0.500 will give us the final level. If you add those together, we get 11.7 mLs as the final answer. And please understand, we are rounding again to 1 decimal place because of this being in 1 decimal place. Okay, the next problem is also similar to something that we've solved previously in a different section of this chapter. So again, a container that has a length, a given height. So we know length and we know height. We need to calculate the width of this container if it can hold 1.50 pounds of a gas whose density is given to us. Now, first hint here is that if it's a container that has a defined length, width, and height, that the shape of this container again is as such, as drawn, right? You've got length, you've got width, you've got height. And if you are working with a container of this shape, that the volume of this container can be calculated by multiplying length, width, and height with each other. Also, if this container is full of a gas, then that will also give us the volume of the gas in this container. Okay, so let's look at what do we know about the gas. We know the mass of a gas, and we also know the density. So our first step in this case should be to figure out the volume of the gas. The volume of the gas can be determined by, once again, dividing the mass of the gas by the density of the gas. So in other words, 1.50 pounds divided by the density 3.35 times 10 raised to minus 2 grams per cc should give us volume. The only challenge here is, though, that we are not ready to cancel any units because grams and pounds don't match. So first step is for us to do that. 1 pound equals 453.6 grams. Grams cross out, pounds cross out, leaving behind cc's. That's volume, which is also mLs. Okay, so when you calculate this, we get an answer equal to 20310.44776 cc's, centimeter cubes. Okay. Now, as we said before, that volume of the container equals the volume of the gas, and the volume of a container is equal to length times width times height. We can say that 5.340 meters times width, we don't know width, times 6.50 inches will equal 20310.44776 cc's. Now note that I'm not rounding anything yet. That needs to happen at the end when you have the final answer in place. Okay, so if that's the case, width will be calculated by dividing the volume 20310.44776 centimeter cube. So I'm going to write that as that. Divide that by length 5.340 meters and height. Problem here at the moment is that we can't cancel anything, so we need to do some conversions. First conversion that we need to do is convert meters to centimeters. The meters cross out, one of the centimeters crosses out as well. The other conversion we need to do is convert inches into centimeters, so that inch crosses out, centimeter crosses out, leaving behind only a one-dimensional property, in this case length. Okay, so plugging in the numbers that go there, 1 centimeter equals 10 raised to minus 2 meters, and 1 inch equals 2.540 centimeters. When you plug in these numbers in the calculator, you would get 2.303727824 centimeters. That's our final answer, just before rounding, of course. This is the answer that should be rounded using the original data. If you look at the original data, the least number of significant figures is 3, so we need to round this also to 3 significant figures, becomes 2.30 centimeters, and that is our final answer in 3 significant figures.